Imagine you're trying to build something that moves. You know, it's got wheels and stuff to make it go forward. How are you going to optimize that? You can't just make a brick with wheels and expect it to go fast. You got to make it, like good and stuff. But how do you go about doing that? Well, most wind tunnels are expensive, and computer flow visualization software is complicated and difficult. Like, what do you mean my part is in the computational domain? What even is a computational domain? I don't know either. Problems like that have led us to create our very own cheap and affordable wind tunnel for the average Joe. By bringing down the cost of a wind tunnel, everyday people like you and I now have access to tools only the top 1% have. People can now improve on their own ideas cheaply and quickly without needing all the money or knowledge previously required. Our wind tunnel could even be acquired by schools at a cheap price to be used as a demonstration tool to inspire the future generation of engineers and scientists. The theme we chose was improving civil infrastructure and civil technologies. We do this by giving more people access to the tools needed to do this, such as wind tunnels. What we identified as a major problem was the cost of a wind tunnel, as most everyday people, like you and I, don't got all the money needed for a commercial wind tunnel. To solve this, we chose cheap materials that many people have access to. These materials included things such as wood as the main structural frame, which then cardboard rests on and acts as the main material of the wind tunnel. Lexan was then used as the viewing window, creating an easy way of actually seeing the object. A simple cheap box fan was chosen as the main way of pushing the air along, with plastic straws that straighten the air, allowing for the laminar flow needed in a wind tunnel. To further drive costs down, we designed it to be as simple as possible to make it as easy as possible to make this wind tunnel to be produced. As stated before, we designed our wind tunnel to be as simple as possible. We achieved this by using simple shapes and having an overall simple geometry. While this may come with some performance compromises, we deemed it negligible to the overall goal of our project. Our design starts with a 15 by 15 inch intake, which then funnels down into a 7 by 7 tunnel, which includes the straws for the laminar flow in the viewing platform which the object actually sits on. After the viewing panel, it goes into another array of straws, which then funnels into a large box fan at the end. Going into a bit more detail, on the middle section with the viewing panel, it includes a clear side made of Lexan to see into the tunnel, and the top will be able to open up to put objects in and out along with the hole for a smoke tube. By doing all these cost-cutting measures, we managed to get the price of our wind tunnel down to under $100, which is very much in the budget for most everyday people. While the design focused on earlier was one we deemed to be the best suited for our goals, we went through several iterations and ideas before landing on it. In some of our designs, we were going to use computer fans instead of a box fan due to its lower cost. However, the complexity and smaller size did not justify the cheaper price of it. The choice of materials is also something that changed quite a lot during our design process, as initially we planned to use foam boards instead of cardboard thanks to its better structural rigidity. However, after doing some testing, we found that cardboard performed just as well, and it was cheaper to use, and it was easier to work with. Also has the added benefit that it's readily available. To be quite honest, due to some of the setbacks in our building process, along with some delays in obtaining the materials needed, we weren't able to finish the wind tunnel by the time of this video's creation. However, we have been able to test parts of our wind tunnel to confirm everything works. The box fan works well with the shroud, funneling air into a smaller space, which speeds up the air, creating the proper airspeed needed for the laminar flow. We have tested our smoke machine and it works quite well. A little bit too well, to be honest, to the point where we have to dilute it as it produces too much smoke. The only part that we have yet to test is the straw array to make sure the air comes out laminar. However, we don't see any issues arising due to this. Throughout the course of doing this project, we have learned many things, ranging from very simple things such as how to actually properly cut cardboard. It's actually a lot harder than it looks, to much more complex things such as how to work with your teammates effectively or work into your own strengths. A big change our team would have is setting up an easy way to contact others early on rather than waiting to do it, as our team waited to do it and we suffered as a result. But to end on a good note, our plans for the future is to finish assembling the wind tunnel, do final testing, and have it ready for the in-person presentation next Monday. Everyone in our group has learned a lot throughout this project, and we plan on using the skills and knowledge learned during this class and apply it to future projects, classes, and even jobs in the future.